In this video, I will do the first example, very basic example of a method of Lagrange multipliers. The problem is find the minimum of f of x, y, which is x squared plus y squared, subject to the condition x plus y equal to 0. The first thing to note here is that the condition is not written in a nice way. Remember, well, f of x, y is x squared plus y squared. The constraint always needs to be written as gxy equals to 0. It means that bring everything one side, call it gxy. In this case, I can bring 1 to the left, and then I can have gxy is equal to x plus y minus 1. Okay, so now we want to form the function. So the step one is, or form the function is x, y, and lambda. It's a function with three variables. It's x squared plus y squared plus lambda times the whole gx, which is x plus y minus 1. Then step 2 is find critical points of this. So we need to find fx equal to 0, fy equals to 0, and f lambda equals to 0. So fx here is what? So I have 2x plus, this is 0, plus this is lambda times x. You should remember these pieces that you multiply. The only piece which has x is this, and that gives me just lambda. This is equal to 0. If y means 2y plus lambda again equals to 0. And if lambda is just this piece, you remember if lambda equal to 0 always gives us the condition, the constraint. Now we need to solve this thing. I have three equations to solve. What you need to do, use two first one and write lambda in terms of x and y. So I can write lambda here equals to minus 2x. And then use here is lambda is equal to minus 2y. Well, if you can do that, then combine these two, because this piece is equal to negative 2x is equal to lambda, and negative 2y is equal to lambda. That means that negative 2x is going to be equal to negative 2y. That means that x needs to be equal to y. We haven't solved the equations because now I just have another equation, which is this, and I need to consider the constraint, or the third equation, put them together and solve. So let me just write once together these guys. X plus y minus 1 equals to 0. But this is easy. The first one says that set x equal to y, so you go y plus y minus 1 is equal to 0. That means that 2y equals to 1. That means that y is equal to 1 over 2. And then look at the first one. If y is equal to 2, then x is also going to be equal to 2. So there's only f has only one critical point with x equal to half and y equal to half. Well, someone can also find lambda. Lambda also here can be found. I can use this equation here. Lambda is negative 2 times x, which is negative 1. But we don't need it. We won't use lambda while trying to. And then that means that if this is the only point, only critical point, so that means that the minimum value of the constraint optimization is given, oops, sorry, is given by f at half, and x is half, y is half, so it will be 1 over 2 squared plus 1 over 2 squared, and this is 1 over 4 plus 1 over 4, you add them, you get 1 over 2. This was an example that I did in the introduction video, but here we use the Lagrange multiplier, and we form the function. This is the function. Then we find the critical points, and that there was only one critical point, and that needs to be the minimum of that function constraint to that condition.